Hello, we're going to work on a momentum problem, a momentum and collision problem. So we have car A has a mass of 2,000 kilograms and a velocity of 70 meters per second. So car A, 2,000 kilograms is its mass, and its velocity is 70 meters per second, and ignore this for now. And then it collides with car B, which has a mass of 1,700 kilograms, and it is at rest. At rest means that we're going to use 0 meters per second here. After the collision, car A stops. So this is all before. After the collision, car A stops. We don't have to put its mass here because the mass stays the same. But now it stops, it's at rest, so it's at 0 meters per second. What is the velocity of car B after the collision? So we've got our before and our after. We've got our masses and our velocities. I could have rewritten the masses over here, but I just chose not to. And so now I'm going to say to myself, is this elastic or inelastic? They didn't indicate that the two cars locked together. Usually problems that are inelastic will indicate that. They just said that we've got these two cars. And also, if you think about like pool balls, it said that car A was moving and car B was at rest, and then they collided and car A stopped and car B is going. So that also indicates that we've got an elastic collision here. They don't lock together. So we're going to use this equation, MAVA plus MBVB equals MA capital VA plus MB capital VB. So I colored these dark blue and light blue to indicate that we're in the before area here when we're doing this, and then dark green and light green to indicate the after. And our masses, of course, stay the same. The masses of the cars don't change. So I've got the 2,000 times 70 for car A's mass and velocity, 1,700 times 0 for car B's mass and velocity before the collision. And then we go to after, and we've got 2,000 times 0, the mass of, sorry about that fly, the mass of car A, which stayed the same, and then it's at rest, and then we've got 1,700 times capital VB for car B after the collision. It looks like a lot, but because we have a 0 here and a 0 here, we know that 0 times anything is just 0. And then 0 plus whatever this will be just this. 0 plus 1,700 kilograms times VB will just be 1,700 kilograms times VB. So you can see here, multiplied these two, carried this down. This was just 0, so nothing else happened. This was just 0, so nothing else happened. I carried this down. So I need to get VB isolated. The next thing I'm going to do is I'm going to divide both sides by the coefficient here. The coefficient is the number that's times or multiplied by the unknown. The number times the letter is what I often say. So we're going to divide both sides by 1,700. Anything divided by itself is just 1. And 1 times VB will just be VB. And so here I've got the 140,000 times, or divided by the 1,700. The kilograms cancel out, leaving me with just the meters per second. So that is how you do an elastic collision problem.